My name is Michelle Czamanske. I am the academic advisor for the undergraduates here at Virginia Tech, Material Science and Engineering. Along with us tonight is panelist Anna. Anna, would you like to introduce yourself?
Hello, everyone. My name is Anna. I'm a senior here studying material science engineering with a minor in green engineering, and I'm from Western New York.
All right, so let's get started. You guys are here to learn about what is MSE. MSE is Material Science and Engineering. One of the many things we do is we study the different materials, how they behave, why they behave, what do they do naturally, and then we take that knowledge and we engineer it to do what we want it to do. Okay, that's a very simple explanation. There are four basic materials we work with: metals, polymers, aka plastics, ceramics, and electronic materials. Everything else would be a composite. And in addition to that, we also identify biomaterials as a specific material that we work with. I'm going to pause and let's see if Anna has anything to add from the student perspective.
Yeah, so we have to take an intro class in four of these. So we have to take a ceramics class, an electronic materials class, a polymers class, and metals class. And then basically once you take all of those, you can decide like which materials interest you and take all of your tech electives based on that. So these ones that we have listed here are some of like the basic foundational materials, and then things get like more detailed as you go on. But MSc is awesome, and it's really very broad and applicable to a lot of different industries.
One of the ways I like to describe material science and explain it to people is there's a couple different ways. One is I will use a sport. If anybody would like to type in or in the Q&A and identify a sport that they play, we can talk about the sporting equipment that is used in that and the advancements that it's made over time. Okay. Anna, do you work in the helmet lab or have you?
No, I haven't worked in the helmet lab, but a lot of my friends have, so I know a little bit about it.
Okay. So we have, let's see, tennis. Tennis is an excellent example with this. When tennis was first designed and invented as a sport, the wooden racket was very heavy. Okay. And they did try to find the lighter weight woods, but it's still a very heavy piece of wood. And the strings that they used were goat gut to make the strings on the racket. Advancements in materials have made it possible for us to make the racket lightweight with different types of alloys. And we use polymer now for the strings instead of goat guts. Right? That's just one example. Let's see, some other people chimed in here. Gymnastics. I don't have too many examples with gymnastics other than the equipment that is used. If you're on a parallel bar or uneven bars, that's what they're called. Those bars have to be strong yet flexible. So it's the design in those that make them that way. And it's the improvement over time, because initially they were made with a heavy piece of equipment that would not travel very well. It still doesn't travel very well because it's so big and bulky, but it's stronger now and it can hold more weight. Okay, that's a good one. Gymnastics I haven't had before. Soccer, I have done a lot with soccer in that our students do a research paper. And several years ago, a student did a research paper on the soccer ball and said if it was designed differently, would it kick further and faster? Would it travel faster and farther when kicked if made differently? Because if you look at the soccer ball, I think they're octagons that are stitched together around, and it's always leather. So if you change that up, how is it going to change the sport? We can also talk about soccer and most any sport when we talk about the shoes that people wear, right? Runners and soccer players, baseball, and basketball, anyone will tell you that they go through a number of different shoes because of the impact that the shoe takes. So as you're running and you're putting pressure on the shoe, every time that polymer absorbs it. And every time that polymer gets weaker and weaker and flattens out. So you'll find that you go through many different pairs of shoes for these sports, right? A material scientist in the polymer field is going to look at that and say, how do we improve that? How do we improve the polymer so that the impact, it takes more of an impact and you don't go through as many shoes? And also, how do we improve it so it's better on your ankles and your knees? So it absorbs more of the shock than your knees do. Okay? Very good sports. Let's see if there was one that's new here that I haven't. Rock climbing. Okay. The gear that is made for rock climbing has to be specific and it has to be weight tolerant, right? You would not go rock climbing with something that you just picked up at Walmart. Actually, many years ago, we had a student, Sarah, she graduated. She's actually back now working on, I think, her PhD, who worked for, uh, goodness gracious, I can't remember which company it was, but she developed a new rope for rock climbing. Okay. Also, the clips that you use, they have to be at a certain tolerance to hold a certain weight when you rock climb. Right. You would not go up there with something that I use as a shelter to keep a dog cage closed. That would just be disastrous. All right. Anna, do you want to chime in and throw in anything on these sports and improvements?
Yeah, sure. So one that I like sometimes use in interviews for like answers is field hockey, because I played field hockey in high school, and those sticks used to be made out of wood, and a lot of times like people that have older sticks, those are made out of wood, but now they're made out of like fiberglass and different composites reinforced with like graphite and just stronger materials. And it's actually kind of cool because when you're playing field hockey and people have wooden sticks, I've been in games where literally the stick will just snap in half, but only ever to the people using wooden sticks. So it's kind of cool to be able to see that in action, and now looking back on it, realize like why that happened. But this is
Mm-hmm.
just one area of MSE, and it's okay if you're not a big sports person. It's not everything. It's just an easy, relatable example that we like to use.
Exactly. This is a very relatable. And I just want to chime in and add to what Anna said. Hockey too. Hockey is always mostly used with wooden sticks, and those players go through probably two or three sticks a game. It's just it's crazy. But yes, sporting is just one way to explain this and the advancements that we have made over time using material science and engineering. Right? It depends what we are designing for and what improvements we want to make. I say we, it's not really me, it's you guys. It's Anna. I'm just the academic advisor here. Um, there are so many different things and advancements that have been made over time. I can tell you, going back, I wear contacts. These are my reading glasses, but I do wear contacts. When contacts were initially invented and designed, they were hard lenses. If anybody's ever worn contacts before, you would. I don't recommend those hard lenses because it feels to me it felt like there was a grain of sand in my eye. But now they have these soft lenses and they're fabulous. And I don't even feel them in my eye anymore. So, um, in every area, there's been an advancement because the new material has been designed to help that. All right. And I challenge anyone and everyone to make something without a material. It can't be done. That's why engineering is very important. So, as I just said, material science and engineering is the center of most, if not all, engineering because you can't make something without a material. What material you pick is going to determine how well the product works or how long it works, actually, going back to the tennis shoe example. Anna, would you like to jump in and share a little bit about this slide or talk about? I think you've seen it before.
Yeah, for sure. So, like I mentioned before, MSc is just really a ginormously broad type of engineering. Like Michelle mentioned before, literally everything is made out of materials. So there's kind of a spot for a material science engineer everywhere in every industry. So you can see here the ones in yellow, like we talked about before, are like the central materials, and then all of these blue things around the edges are applications you can get into using these materials. So just some examples of positions and industries you can get into just as a materials engineer. And something that I can like personally tell you about being a materials engineer is that I worked at GE Aviation working on little small parts for jet engines. And my position was actually called a quality engineer. But all of my MSE background is what made me like eligible and useful for that position. Even though I had no experience with quality, I didn't know anything about any of their standards. Having the background of how all these materials and stuff work and how things like need to be processed and what happens when things fail, like that background is what you apply to any one of these types of engineering. So it's really, really awesome how broad it is, and you can kind of make it whatever you want. You can do materials research forever. You can bounce around between different mechanical positions, quality positions. It's honestly awesome, and you just get this skill set and this knowledge bank that's applicable to anything that you want. A couple people I know want to work in the makeup industry and learn about the chemistry of like mixing the makeup things and all of that. And then some people go work for Nike and work on making the soles of the shoes. It's really, really just a way for you to get into whatever your passion is. So I hope
Mhm.
you can see by this slide that MSE encompasses pretty much everything.
Mhm. Whatever industry there is, they need a material scientist to say, build it with this design, or use these materials to make that product. Okay. This is an example. You can see aerospace at the bottom here. Our students go work for aerospace because they need to make the plane lighter and stronger. Okay. Lighter uses less fuel, stronger in the unfortunate event of an impact landing. Okay. In the aerospace industry, every one of these biomaterials, polymers, metals, electronic materials, ceramics and glass, and composites is used. Okay? I had an interesting meeting a while ago with a company that makes asphalt. Right? And I never thought about asphalt before because, it's always there. It's on the ground. We drive on it, big deal. But they are making, and all airports have to have a fire retardant asphalt. Okay? And so they have a, a contract where they go around putting in fire retardant asphalt in the unfortunate event of an impact landing. And to me, that was actually quite fascinating. And there's so many different advancements right now in asphalt, and they're making the asphalt that is fire retardant, but they also make some that rainwater runs through it so it doesn't puddle on the roads. Um, we have had alumni work in almost every industry from NASA to Yankee Candle. And it's been pretty interesting to see the different companies that our people go into in the different fields. So,
Yeah,
um,
that's awesome.
again, I'm going
You
to say if
get
you guys have questions, go ahead. Anna, what were you saying?
Yeah, absolutely. I'm just going to say you get a really diverse perspective coming in as a materials engineer. And what you were saying about aerospace engineering, the project I was working on were making parts instead of making them out of metal, we were making them out of composites, ceramics, to make them lighter and more fuel efficient and stuff. And again, I did not know anything about engines, had never taken an aerospace class, and I was able to just get in there without missing a beat just because of that materials background. So it's
Mm-hmm.
awesome.
Mm-hmm. I mentioned, and Anna has alluded to this as well, what material scientists do is they look at how to make the product so we can make it stronger, better, lighter, whatever the need is. And that's the important thing. What is the need? So again, with an airplane, you want to make it lighter and stronger. How do you do that? Um, and that's taking these raw materials and mixing them together in a specific way that makes the outcome you're looking for. And that's, Anna, you're in ceramics, is that correct? Yeah. And that's one of the things that they do. Um, I relate this very simply to making a cake from scratch. All right. And I challenge you guys, let's say Mother's Day and Father's Day is coming up. So for Mother's Day, make the cake according to the recipe. All right. You're going to take your sugar and your egg, you're going to mix those together. You're going to get a nice frothy goodness. Okay. You're going to add your other wet ingredients and then finally your dry ingredients. You're going to bake that and get a cake. Do that for Mother's Day. For Father's Day, take the recipe and do it almost backwards, okay? Start with the dry ingredients, add some wet ingredients, add your egg and sugar, add the butter, bake that and see if you get the same cake, right? No one has yet to come back to me and tell me how it turns out, but I'm pretty sure it's not going to work because scientists and bakers have figured out the best way to make a cake. Step 1, 2, 3, 4. And that's what a material scientist does when they play with these different raw materials to try to get the best outcome. So we play with it 1, 2, 3. Does that work? No, it didn't work. Okay, 3, 2, 1. That didn't work. 2, 1, 3. That worked. That's how we got it. So, very simply, your guys are bakers. And I know that's not an accurate representation, but it's a very simple representation of what they do in the lab when they're building things and playing with things and putting them together in different orders. Speaking of the lab, hold on, let me see if I can advance this screen. Our students are in the lab doing the work almost every semester. Okay? Plan correctly, you will be in the lab every semester. And you will be the one doing the coursework, doing the lab experiment. We work very hard to make sure our labs are small so that the students get to work and not sit back and watch the grad student or the instructor do the work. Anna, you want to tell them about some of the labs that you guys have done?
Definitely have been in the lab every single semester. It's awesome. And Michelle is telling the truth. Like, it is a small group, and that professors, you're like asking how to do something or asking like, what am I doing here? And you really, really get legitimate hands-on experience like all the time. And some of the one of the really cool labs that I took as an elective is called the ceramics and glass lab. And in that, we actually got to learn how to slip cast a ceramic vase, and then we made our own glaze for it by doing glass. You like melt glass, and then you pour the hot glass into cold water, and it comes out in this curly pattern, and then you smash it up and use it to make a glaze. So it was like this whole big thing. We made this vase and we glazed it, and it was really, really cool because we got to learn from like every single step of the process. Even when the first two vases failed, we studied the crack surface and the fracture surface. We cut it up and put it under the microscope to look at what went wrong. So that's definitely my favorite lab. But we also have a really, really cool senior design program here. So in the spring of your junior year, you get assigned a senior design group based on your ranking of some projects. And then starting in spring semester junior year, all the way through the end of senior year, you get to actually go in individually with your team of 4 people and work on a group project totally by yourself. So it's honestly so awesome to learn all these skills and be able to independently go do work in the lab and know how to use all of these machines and everything. So taking all of these labs leading up until your senior year is really great preparation to give you those skills and everything that you need to actually go and pursue this project and be the leader and make your own like lab experience. So the labs are awesome, and it's fun because you're just hanging out. You got your friends in the lab. You're learning how to do stuff. Everybody's laughing, so it's a great time.
It's a great time. Um, so with our undergraduate labs, like we said, we have 5 specific labs, and there's different equipment in each one of them, and they bounce between the rooms depending on what they need to do. We have a furnace lab, and where they put things in, they heat them up for various reasons. I'm going to jump to this picture that we're looking at right here. We have our very own foundry, and our students at the foundry get to pour what you see there, molten iron, into different projects and different things. We also have this semester going on right now, and every other spring semester, a bladesmithing class where students actually make a blade for a contest. I don't know who's going to the contest this year, but they're finishing up their blades now. And I talked with a student earlier today, and they were doing strength testing and to see if it would cut a wire. So there was a wire on a tension rod, and then they used the blade to cut. And from there, they made modifications to their blade as they needed to. We have about 19 to 20, depending on the year, faculty member that ranges from full-time to part-time. Most of our faculty are cross-listed because MSc is so interdisciplinary with the other majors. Some of our faculty are MSc and Chem. Some of our faculty member are MSc and ECE. Okay. At most, we've had 250 undergrad students. We're down to about 210 now. All right, but we are one of the fastest growing MSc programs in the country. Very exciting news there. Let's see. Student life in MSc. All of our students are members of what we call MEPS, which is Materials Engineering Professional Society. And Anna is actually a member, and you're on the committee, right? You're on the board.
Yeah. So MEPS is really cool. I joined as a sophomore during my first year in the materials science and engineering major. And so I've been in a position on that executive board ever since. Right now, I'm the vice president. But basically, what we do is coordinate outreach into the community. We coordinate social events for everyone in the major. We do we take care of all the design teams. So it's really a cool organization, and it's a great way to unite all the students because, as you can see, we do have some department. So it's a lot more of a close-knit community type feel, and especially having this organization to get all our social events together. It's a great way to make sure everybody's friends and everybody's getting to hang out and enjoy life. We do cool stuff like around Halloween time. We always have a game tournament. Smash and other Switch games, and it's like a whole big tournament you enter. That's super fun, and we do local volunteering events at elementary schools and go do science demos and stuff there. So it's a great organization, and it's awesome to be a part of a community where everybody just likes to be involved and hang out, and everybody's down to do whatever MEPS has planned. But I've loved being involved in it, and it's been a great way to make friends.
Mm-hmm. So Anna alluded a little bit to design teams. We have several different design teams that compete. MS&T is one of our big conferences that we go to, and it's a student-driven conference. And at the conference, the students compete their design element against other colleges. I'm going to go ahead and brag and say we've won first place most times. I'll let Anna follow up on the different design teams that there are and the different activities that you can get in. But some of these pictures, the picture in the bottom right, is students that were at a conference for the design competing.
I have a broken piece of something I used to compete in a design team. Not this fall, but last fall, we went to Portland, Oregon. And if you didn't catch the name of it, M&T stands for Material Science and Technology. This is a piece of a disc that we made. So one of the design teams is called the ceramic disc team. And there's two competitions for this team. One is an aesthetic competition, and the other one is a disc golf throwing competition. So this is really cool because they give us requirements for a disc, the diameter, the thickness, and how thick this like little lip around the edge has to be. The temperature has to go up to. They give us all of these parameters that we have to meet, and then they're like, okay, go make a disc. So we make a disc, we bring it to the competition, and then the way that we compete against other schools is they have those metal disc golf nets set up and a bunch of set distances away from the net, and you literally have to throw your disc into the net.
One of the other competitions that they have is the dome disc, Doomsday, and this is it. It's a lightweight dome that the students have to build. So they have to make a dome, lightweight. It is put into a machine and weight is pressed upon it, right? We have won that contest, first place for the past 5 years, second place 1 year, all right? This dome that I'm holding here will hold the weight of a small car, okay? In subsequent years, we've built one that will hold the weight of a medium-sized car, and that one maxed out the machine. Okay, so imagine putting a Prius, if you will, on the weight of a Prius on this, and it will hold. Right, that's what we do. All right, we do have 2 questions. And study abroad. Yes, study abroad is possible. There's several different opportunities. If you want to go for an entire semester, that can be arranged. We work in advance to make that happen because we have to make sure that the classes you take abroad transfer back. We want it to be a good use of your time. Most students who do that for the whole semester look at things for their liberal education or their, and not always definitely specifically for their major, Okay. There are programs where you can go for the summer to Germany. We haven't gone to China in a number of years. Those opportunities are typically 3 to 6 weeks doing undergrad research abroad. Okay. Other questions? Let's see.
Somebody asked about the foreign language study too. I also want to jump in and add, there's also ways to go study abroad without taking classes too. You can go do research abroad. So last year, actually, one of my friends and I, one of my classmates, I guess, we're supposed to go with our professor to Ghana to work there for 2 weeks and study something. Obviously that got canceled, but there's all sorts of opportunities to just get involved in random things like that. And for studying foreign language here, it definitely is a possibility. There's a lot of people that do minors in languages. I've taken a handful of German classes here because I took German in high school and I really wanted to continue. So definitely an option to get involved with foreign language and to study abroad.
Definitely. Now, I would say if you're going for the three-week program, a language is not required. All right, but it is recommended because you want to be able to order a pizza and sound coherent. Another question is there a 5-year plan to get a master's? Yes, there is. It would be what we call the 5-year accelerated program, so that your senior year of your undergrad is your first year in grad. And the classes that you take for your technical electives count in both areas. All right, there's a number of students who are taking advantage of that opportunity right now. I highly recommend it for everyone. I do tell everyone that you need at least a 3.3 GPA to be considered for that program. So start working on that right away. MSc is not a minor. We are major only. Okay. You can do an MSc and minor in other areas. So we have students who are minoring nanoscience, a foreign language, economics, technical writing, you name it, they've done it. Okay. Another question is MSc in the new classroom building. The new class, we are actually split right now. All right. Our undergraduate labs are in Randolph Hall. We are building a brand new building right across from Randolph Hall called, well, we're not brand new, Holden Hall. We're redesigning it, if you will, and adding brand new labs and everything. So MSc is going to, our home is in Holden Hall, but our classrooms are taught everywhere. Anna, you've been...
I've had some classes in new classroom building. We have to take a programming class, and some of those have been a new classroom building. But you pretty much get classes wherever there's room. It's a lot of times it's in Randolph because that's near where our labs are, but I've had a couple in new classroom building.
Mm-hmm.
And then what are some interesting internships and co-ops that current students have done? So I touched on mine a little bit earlier. I've done 3 rotations at GE Aviation, working on ceramic composite parts for jet engines. And some of my classmates have worked at places like Honeywell, doing materials research there. One of my other friends had an internship in California at a small company called LTA, which stands for lighter than air, and they actually build airships there. So he got to go out to California for the summer and work on these giant sort of blimp things and research those. Let's see, what are some other cool ones people have done? I know one of my classmates worked for Johnson & Johnson in Florida. That was pretty cool.
Piper Air in Florida as well.
Mm-hmm.
So.
A lot of people get to work at Corning. Corning are the people that make the glass that's on your iPhone screen that's supposed to not break, Gorilla Glass. They also do glass, optical fibers and stuff like that. A lot of people get to work at Corning because there's a Corning location that's actually not far from us here in Blacksburg. So tons and tons of cool opportunities. Those are just some off the top of my head I can think of.
We also have a lot of people do co-ops. So I would say that if you do a co-op, that's going to take a semester, maybe more, and you'll probably graduate a year later. So it's not going to be a 4-year plan. Don't let that deter you. A co-op is an excellent opportunity and idea for everyone. Okay. Anna, you touched on your green engineering minor. Someone's asked, is it relatively easy to add the green minor?
Yes, it is very easy to add the green minor. I added the green minor. You really just need to choose your technical electives and your path based on fulfilling the minor requirements. It's not been hard at all for me to incorporate that into my schedule, and a lot of my classmates are doing it. So it's also helpful to have all of them in the classes with me so that it's just kind of like another MSc class. So I definitely recommend it if you have any interest in green engineering or having a little leg up behind your MSc degree. And then the next one, asking if you can major in MSc while being in ROTC and playing a sport. You can do anything as long as you manage your time well. It's all about having your own discipline, and there's a lot of support here for people in terms of time management, tutoring, helping you with your schedule. So I say yes. It's ambitious. You are going to have to do, be disciplined with yourself. But if that's something that you're passionate about, all 3 things, then yeah, absolutely you can.
Mm-hmm. I'd interject here as the academic advisor and just agree with Anna. Yes, it is possible. Time management is very key. Most of our students are, you said ROTC, so I'm not sure if you're going to be Corps cadets or you're doing ROTC reserve. And those are 2 slightly different things. Similar outcome, just different things. If you are going to be Corps cadet working for the naval career, yes, it is very possible. I would ask if your sport is a club sport or other. If it is other, which we've had many students play sports and be successful here in MSc. We've had some wrestlers in the past, and we've had tennis players, some people on the track team. So yes, all of these things are possible. I would look very carefully at making it. With the Navy, there's additional requirements So it might be that you're at 18 to 19 credits per semester hour, and we look at extending that and graduating in 5 years, just so that you're not spreading yourself too thin. I'm very key on balance and making sure everybody has a little bit of time in their day. All right, there is another question. MSc
There's some about
minors.
minors. So these are both to do with minors. You can minor in any minor you want. You don't have to stick with engineering or MSc or anything like that. You can minor in a language. You can minor in literally anything. The difficulty is going to increase a little bit as you get further and further away from engineering concepts. So the reason that it's so easy to major or to minor in green engineering is because there's a lot of overlap between the classes that count towards your MSc degree and the classes that count towards the green engineering minor. So with a minor like business, it's going to be a little bit more difficult. You might have a couple bit more credit hours per semester just because a marketing class won't necessarily overlap with like an electronic material class, you know? So there's no limit. You can do that if you want, if that's something you're interested in. We encourage everybody to explore their interests outside of engineering. But like Michelle was kind of touching on with the whole sport and ROTC thing, you want to make sure that you're not spreading yourself too thin. You're just going to have to manage your time.
Our students look at different minors for different reasons, okay? I like to say that they're going to do one of two things, either provide you diversity, and that's something that you're interested in outside of engineering, right? If you've always had a passion, I have a student right now who's doing an art history minor, then that's fantastic. That's providing you diversity in your day, and it provides you diversity with problem solving for engineering. It gives you something that enhances your abilities, okay? A minor can also enhance your career potentials. Right? If you want to be a code breaker, then a math minor might be a good thing because it's problem solving on a different level. Okay. And most employers are going to look at your minor as, did it provide diversity to you, or is it enhancing your career potentials in some way? I would be very careful about adding a business minor. Any company that's worth a grain of salt who's going to hire you would pay for you to go get an MBA, right? So if that's something in the back of your head, like, I want to go get this, I need a business minor so I can do this. Is that really why you want it? Or do you want to look at something like the entrepreneurship minor, which is actually a very good minor for students who want to break out on their own and start their own company one day? So can you get a dual degree with material science and chemical engineering? Yeah. The difference there, okay, material science and engineering and chemical engineering, they are similar fields, but they're very different fields. They're very different in that chemical engineers are responsible for making large batches of ice cream taste the same throughout the entire process. So the first batch they make tastes this way. The second batch, does it taste the same as and then how do we make that bigger and bigger and bigger? Right? How do we make 500 gallons of ice cream today and make it taste just as good as the 5-gallon batch we did yesterday? Right? A material scientist invents the flavor. Okay? That's where there's a slight difference in the two. We use some of the same principles and processes, but it's what your goal is that we look at. Anna, you want to add to that?
Yeah, absolutely. I do want to go back really quick to the minor thing. It's definitely, did I freeze again?
No, you're good.
Okay. Okay. It's definitely important to think about the implications of choosing a minor on your career, but it's also okay to choose a minor just because you like it and just because it's cool and fun and interesting. Definitely a good idea to keep in mind, like what Michelle was saying about the MBA and whatnot. But if it's just something you think would be cool, that's totally fine.
Yes.
And then regarding the chemical engineering thing, it would be really hard to major in both of them. I'm not going to sugarcoat it. It would be really hard. Not impossible. And again, it's all about where your passion is and how your time management skills and your self-discipline are. But one thing that is really important to keep in mind when you're going to college is that, like, you're going to have so many opportunities and so many things going on and so much to do that you don't want to put too much on your plate. I know it's a really hard concept, especially coming from high school. I feel like I was that person that just did literally everything all the time. I had my Google Calendar was just full. I was doing every club and it was fun and it was awesome. But college is a lot different. just because of how your time is kind of scheduled. So it's awesome to be ambitious and passionate and have goals. But if you get here and you can't do a double major in MSc and chemical, that's nothing to beat yourself up about, because they're both really valuable degrees on their own.
They are. We've had many students come from chemical. We've had students come from mechanical, aerospace. I think the only place we haven't had someone come to is from CS. So come from CS. And I'm going to add to what Anna has been saying. So an average credit load for a college student is 15 credits. All right. That's 15 hours in class of coursework every week. To do well in college, you need to times that by 3. All right. So it's 45 hours outside of class on classwork that you will be doing a week. Right. And that's just to do well. If you want to do exceptional, you need to times that by 4. So 15 times 4. I didn't do that math. Sorry. It's a lot more than 45 hours a week. So take that into consideration when looking at what you want to do and what you want to get out of college. Because yes, it is, you are here to learn, but you're also here to grow as a person and explore and be a college student. I'm not going to deny that's impossible. That's what you're here for.
Yeah, for sure. And it's okay if that number is intimidating to you, all those hours. It doesn't feel like that much because you're doing it with your friends, you're doing it with your classmates. It's like, it does not sound as miserable as those numbers. I promise.
Oh, no.
If it was that bad, I would be like crying and stuff right now. So don't worry. Don't get scared. It's fine.
Yes.
Someone asked if there are any Wear Lab projects that focus on MSc concepts. So this is actually a really good question because our MSc specific design teams are not housed in the Wear Lab, but a lot of times the Wear Lab teams will come to our MEPS meetings, the organization that we talked about earlier, and ask us for help. Say, please, we have to do last year, I guess, I think maybe the Bolt motorcycle team had to do something with like a ceramic disc thing, like, I don't know, some gear or whatever. And they were like, hey guys, we have no idea how to use ceramics. We don't know how to cut them. We don't know how they work. Like, can you please help us? So it's kind of cool because, like we've kind of been mentioning this whole time, there's there's materials involved in every single project ever. So while there aren't any really specific materials projects or teams in the Wear Lab, all of them need material science engineers. I would say the closest one to material science is called Concrete Canoe, because concrete is a material and they have to figure out how to make a canoe out of concrete, make it the right shape and size and weight in order for it to float and they can race this canoe. So that one I would say is probably the most materials specific, but all of them need materials engineers, and it's kind of fun to have all of these random people from design teams be like, hey, can you please help us? Like, we don't know what's going on, and find your kind of place within those teams.
Mm-hmm. We've helped out many different teams before for that reason. There was, I think the Baja team several years ago built a part and it broke. They built it again, it broke, probably 3 times. And then they finally came to material science and said, why is it breaking? Please help us. And we did. We have students on different teams too, actually. I have a student on Formula, Baja. There's students who do work at the Helmet Lab, which I mentioned earlier. It was a really neat project that one of the students was working on was on the mouth guard. And they had a prototype that another classmate was wearing when she was playing field hockey. It was testing and recording data on the impact that she took whenever she would fall or get hit or something. Very fascinating stuff. We have just a couple minutes left. So as I mentioned earlier, there's a follow-up session starting at 7:00 tonight where we're going to give you an online lab tour. We go through the labs and we give demos and such. Please come back for that. Any last minute questions? I did provide my information. If you want to send some questions to me and or to Anna, I can get them to Anna.
Yeah, and I just put my email in the chat too. If
she did. There we go.
I'm more than happy to answer any questions at all. I know it's kind of sometimes like awkward to ask them from other people, but if there's anything I can do for anybody to help you out, just let me know. I'm involved in a bunch of clubs outside of engineering and stuff too. So if you have any questions about that, let me know.
Mm-hmm. And that is one thing that I would highly recommend. On this campus, you'll find that engineers are a dime a dozen. You need to be that 2 cents, if you will, that stands out. And by standing out, I mean you need to have leadership experience on your resume. And that's something that we will help you work on. And Anna's got tons of that.
That's true. I counted it up the other day, and I think I'm on the executive board of like 5 or 6 different organizations. So it's a good time. It's fun, and a lot of them are not engineering. So it's again a good way to diversify yourself and make friends and really get everything out of college that you can.
Yeah, my recommendation, which Anna has exceeded this, is to find 2 organizations and be on the executive board of those 2. One for your major, one engineering related, and one is a personal interest that you have. There is a surfing team here at Virginia Tech. We are nowhere near the ocean, but there is a surfing team. So be on that exec board. If you like rock climbing, which someone mentioned earlier, there is a rock climbing club. Be on that committee.
I'm on the Castle Guard executive board. I'm the vice president, which is our basketball fan student section. So I just get to organize like t-shirt giveaways. I run the Twitter account and the Instagram account. So if you want to hit at Castle Guard VT with a follow, you'll see all my tweets. But that's really fun, and it's like not even really like I'm doing any work because it's just me being a basketball fan. And then I'm in an organization called Teach for Jamie, where we go teach German to local elementary school kids after school. So it's like a little hour long after their school day ends. We teach them how to say stuff in German and play, games and stuff. So there's something for everybody here. There are so many different clubs, and if you can't find a club here that you're interested in, then you can just start one that you're interested in. Mm-hmm. That's what people do all the time. So
yes, there's even a chocolate milk club.
Chocolate Milk Monday club. They go to a dining hall every Monday that serves chocolate milk like out of these big containers, and it's from the local farms, like the farms in Blacksburg, and they just like drink chocolate milk and talk about life and stuff. So pretty cool. Good time.
Yeah, it's good stuff. Mm-hmm. All right, ladies and gentlemen, thank you for attending. Again, there's our information. If you have any questions, and Anna put her email address in the chat, please feel free to hit us up. If you're ever going to be in the area, definitely email me and I can get you a tour of the labs. All right. For that, you need long pants and closed-toed shoes, but we'll cover that when you get here. Is that a last-minute question? Oh, no, you are very welcome. We were glad to help. All right.
We love to help.
Goodbye, everyone.
Thank you, guys. Have a good night.